Welcome to the functional JavaScript series. This is the first episode, so we will be talking about functions. Before we start, I would like to talk about the organization of this course. So I will be doing some notes and some coding as we go, and then I will share those notes with you. In this course, there will be a lot of definitions and a lot of new concepts for most of you. So first of all, don't feel overwhelmed. Those definitions are there to help you deepen your understandings. The second thing is that in computer science, the definitions are not really precise. It's not like mathematics. It's kind of funny. There's a lot of fancy sounding words there, but those definitions are not really even agreed on. So don't feel overwhelmed and remember that they are there to help you, not to intimidate you. Let's just go ahead and start. So functional JavaScript. That's our series, and our first episode is about functions. What is function? Functions are units of computation. It's this abstraction that it takes something from the outside and it produces something as a response. And when I say taking something, it also means that it may take nothing and it may produce nothing. And this nothing is explicitly stated. A function is a unit of computation and it takes some things as input and it produces some things as output. I say things because this may be something like a value or something more complex like an object or even a function. So functions may take other functions as input and they may produce other functions as output. So we will discuss it as we go. So let's create this header here. What are functions? So functions are a unit of computations. They take input and produce output. And let me just highlight this like so, and output as well. To use a function, we first need to define it. So how to define a function in JavaScript? Let's see. We say function, we say compute, then we specify parameters, let's say x and y, and then between the curly braces, we specify a set of instructions, a set of statements or expressions, or rather a sequence, because everything must be executed as it's defined. And it may return a value. So in our case, let's say it's a sum of the input parameters. Defining a function means that we attach or associate a name with some description of computation. So with let's say computation description. And this computation description is what happens when a function is invoked. So before we will discuss later what does it mean exactly to invoke a function, but let's try it again. So we have our compute function, and let's assign it to a variable. Let's say a, and let's say 2 and 5, and let's display it. So 2 plus 5 is 7. So we defined the computation, we executed it, and we displayed the result. And this is the result. So in JavaScript, this way of defining a function is called a function declaration. This is a function declaration, and it's called declaration because there is a funny thing that happens in this specific case in JavaScript, is that I can move this line here and move it on top. So I can execute this function before it's defined, and it works. As you can see, it's still 7. If I change, let's say 9, so now it's 14. And this is possible because we say that the function is hoisted, which means that compiler remembers this name, and during the compilation, it can refer to it. It places this function in the memory. So that now when it tries to execute this specific code, it takes this not from, it doesn't go, from the top to the bottom, but it takes this from the memory. So it's able to use it even before it's defined. And that's the reason it's called declaration, because there are other programming languages where the distinction between defining something and declaring something is more specific. So let's move this over here. Okay, to sum up, let's just say that x and y are parameters or input parameters, and x plus y is output. So let's now focus on the input parameters. So function parameters or function input parameters. So let's grab this function we defined before and let's place it here. So first of all, I don't need to specify return value, right? So if I execute this, it's undefined, which means that if there's no return, it returns undefined. Functions always return something. If it's not defined, it's undefined. It returns the undefined value. Maybe that would be better. But I don't have to specify the input parameters as well. So if I don't specify it, I can just invoke the function, without anything. I don't need to pass anything, but I can pass out something, and it's not taken into account. I can also specify some parameters, input parameters, and I can invoke a function with more than what's specified in JavaScript. So now let's focus on function invocation. And again, let's go ahead and grab this code we had. So in JavaScript, to execute a function, you just write a name and add the parentheses. This way you invoke a function. If you didn't specify that, you will get the description of the defined function. You are usually not interested in that. You want to execute or invoke your functions. But in JavaScript, that's not the only way to invoke a function. There are other ways. And one of them is by saying new compute on a function. And this is kind of strange, and I think it's a source of many problems or misunderstandings. But this is a way of executing a function, and it's called a function constructor. So if you execute this, it has some special characteristics. So I won't be diving into that right now, but I just want you to know that there are other ways of invoking a function. And lastly, we can also invoke a function by by typing its name and saying call. And the first parameter is the context. And in our case, there are no objects in which we want to execute this function. We specify this as null. And then we specify parameters. So in our case, this corresponds to what was defined in this function. So now if I display this, see, it should return 3. Okay, it does not because we skipped our return. So let's add it. And there you have it. So we can specify more here. It will take only the 2 first. To replace x with 1 and replace y with 2. So there is yet another way of executing or invoking a function, which is apply. And it's very similar to call. In this case, we specified, again, the context as null, but then we must specify the parameters as an array. So if we execute this, and let's change this, so for example, it executes as before. The result is 5. So now, to sum it up, functions can be invoked with more or fewer parameters than defined, or rather than declared in its definition. Right? So here in this definition, we declared 2 parameters. So, and we can invoke it with 0, or we can invoke it with more than defined, which means that the extra parameters are ignored, while the missing ones are set to undefined, like that. There are some other things here, like for example, the this a keyword and some special variables such as arguments, but I won't be talking about that because we won't be needing that, because we won't be defining our functions this way. We will be doing this differently. With this different method, all this will be simplified and we won't need to know about all those peculiar things in JavaScript. So now let's do a note about hoisting, which means that functions and variables as well. Variables are defined with var are put into the memory during the compilation phase. This way, these functions can be executed from anywhere, even before, in places before the actual definition. So sometimes in some books they say that those names are put at the top of your file. So you can think about this way, but what happens is that the file is scanned, those declarations, those function declarations. And I say functions declaration because this only applies to this way of defining a function. So they are put into the memory and then you can use it from anywhere in your code, which means that you can invoke a function before it's defined. Okay, but we are more interested in this course in some other ways of defining a function. And another way of defining a function is a function expression, which is also known as a function literal. This way of executing a function looks like that. So we are defining a variable and we are saying that this is a function. And again, it takes two parameters. And now let's execute this. So it's 9. So let's try putting it before. And I have an error. This type function definition is not hoisted as with the function declarations, which means that you have to first define it using this function expression and then you can use it after. There are two ways of using function expressions. The first one is called anonymous function expressions. So this is the anonymous function expression, which means that we define a name of a variable, but the function doesn't have a name here. It's anonymous. But there is another way, which is named function expression. And it's exactly as this. Let's copy that and let's fold this. But instead you can define a name. So let's say calculate. And the result is the same. And why is that? This name can be used to refer to this function from within. So if you would like to create a recursive function, for example, you would need to name it, because if you would like to invoke it again, it will be this name over here, not this name over here, which is again something very peculiar and very specific to JavaScript. So we won't be using that, but I'm just pointing this out so you know the difference. And another way or another reason for using named function expressions is that sometimes in some debuggers this information will be displayed and it will be easier for you to find the cause of an error or something. This name, if it's an anonymous function expression and you have many of them, you may not know which function is being displayed in a stack trace or something. But we won't be using that. We will be using something different. And there is a third way, or rather a slight modification of anonymous function expression, which is called IIFE, which stands for immediately invoked function expressions. And this is just, let's say, a trick or just a way to define a function and invoke it right away. And let's try this out. So you use anonymous function. In our case, it takes two parameters. it returns the result. And now we wrap it into parentheses and we add function invocation. So let's say 2 and 8. And let's assign it to a variable. If I display it, I should get 10, like so. You just define it inside those parentheses. You invoke it as with a named function. Sometimes it's useful, but we won't be using that. So just another way in JavaScript to define and invoke right away a function. Okay, so finally, the way of defining a function we will be using through this course, which is arrow functions. And arrow functions are just very similar to function expressions, but instead of typing, so we name a function. So instead of typing a function here, and as before, we can remove the function and we need to use an arrow, so-called fat arrow. So before this was called fat arrow expression and now it's called arrow functions. So why was this introduced? So first reason was that it's just shorter. So arrow functions are shorter. This is subjective, but this way it's easier or faster to write such functions. Another reason is to clarify the semantics. So I just briefly mentioned the this keyword. In this case, we don't have the this keyword. So they eliminated some using this keyword in a regular function through function declaration or function expressions is somehow tricky. You have to know those semantics, and it's a source of many errors. So with this way of defining a function, they decided to get rid of that. So there is no this, even though we haven't discussed that. It just makes everything simpler and easier to reason about. So you should just remember that arrow functions don't have this. If you see this inside an arrow function, it means that it's taken from the other, it's inherited from other functions. So now let's just try to invoke this as before. So it works. The final thing is that there is this thing called implicit return, which means that if we grab our function over here, we can make it even shorter. If it's just a one line, if we immediately return something like an expression, we can drop the return and we have to remove the curly braces and we can just type it this way. So now it works as before. So this way of defining a function is very similar to how you define a function in mathematical sense. It leads to some very concise code, and we will be using that through this course. There is a lot of opinions in the JavaScript community, and some people say that this kind of function shouldn't be used or should be used rarely. Other people say that they should be used more. So there's a lot of different opinions here. In this course, I'll be using only arrow functions because I really like them. And I just want you to know that you may find people who think completely differently regarding the specific subject. And I hope as we reach the end, you will see why I like them, and I hope you will like them too. So before we go, just one thing, and this is not really useful, just a bonus. In JavaScript, functions are objects, which may sound funny. So let's see how it works. Let me define an object. Let's say a person. This person has a name and age, let's say. And now let's define a function. It's called display name with no parameters. Let's do this name. Now those two things, this object and this function, are not really connected one with another. On top of that, there is this keyword, which is kind of strange. So we can connect that. So we can say that this object should be this in this function. And we do that by using the function I already mentioned, which is call and apply. So if we say that display name, and then because functions are objects, I have some methods on those functions. So I can now say call, and instead of passing null, I will pass person, and I will pass parameters, but in this case there are none. And let's assign this to a variable. So as you can see, it's executed in the context of this object. So functions are objects in JavaScript. Okay, so that's all for today. In the next episode, we'll be talking a little bit about the functional theory. I will give you some definitions about some concepts that will be used through this course till the end. Before we go, I would like to just mention that I started a newsletter because I'm publishing many different things. I'm doing this Flutter course, I'm doing some Emacs videos, and now this. So I decided to do a weekly newsletter. So each Friday I'll be sending a newsletter that recaps the whole week of all the videos I published and maybe some other materials, computer science related materials or books or any other stuff that somehow is related to what we discuss through the week in different courses. So if you're interested, please subscribe. So the link for the newsletter is in the description. Thanks, and till the next time.